In this chapter, we shall discuss the different summary measures that describe collected data for a research. In this video, we shall begin with the measures of central tendency. Measures of central tendency describes the center or the middle value of a dataset. This includes the mean, median, and the mode. The first measure of center is the mean. It is commonly known as the average. It is calculated by adding the values of all observations in a dataset and then dividing that total by the number of observations in the set. Here, we shall define two means. The mean of a population data is called the population mean, and it is symbolized by the Greek letter mu. On the other hand, the mean of a sample data is called sample mean and is denoted by x bar. These two means have the same formula. Furthermore, in the research data, it is only the sample mean that we can determine. The population mean is generally unknown because if the population size is very large, it would be too costly and time-consuming to collect data from the population members. Let us have an example. An accountant should lessen the number of errors in a worksheet. A junior accountant who has been working for 10 months commits report errors monthly in his whole stay with a certain company. The following are the number of errors he commits in his 10 monthly reports: 750, 785, 541, and 5 goals. What is his mean number of errors? In this illustration, all the months in which the junior accountant worked for the company were considered. Hence, the mean we are looking for is the population mean. Adding all the errors for each month and dividing by 10, we get 4.7. This means that the junior accountant commits 4.7 errors on the average per month. Let us consider another example. A marathon race was completed by more than 100 participants. A sample of 5 participants were taken and the race times were recorded in hours as follows: 2.7, 8.3, 3.5, 5.1, and 4.9. What is the mean race time of the 5 participants? Since the dataset comes from the sample of 5 participants, the mean we are looking for is the sample mean. Hence, its symbol is x bar. Adding the race times of the sample of 5 participants and dividing by 5, we obtain 4.9 hours. The mean is a reliable way of comparing which has better values between two or more groups or sets of data. So let us have an illustration for this. Consider the mean first quiz scores for two different freshman sections in science. The students from section X got an average of 72.7, while the students from section Y got an average of 69.8. Which of the two sections got a higher score? If we are going to base it from the mean, then we can say that the students from section X got better scores because their average is higher than the students from section Y. Let us have a second example. The following are the times in minutes that new employees need to learn a job from two companies and their means. Company A employees had an average of 24.6 minutes, while Company B employees had an average of 25.4 minutes. Which company has fast learning new employees? Based from the mean, we can tell that Company A has fast learning new employees because of its lower average compared to Company B. We note here that lower time values would mean better values. As a remark for the mean always exists and is unique. It is the most common measure of center. However, it is greatly affected by extreme values. A very small or very large value compared to the other values of the dataset would change the value of the mean significantly. The next measure of center is the median. The median of a set of observations arranged in an increasing or decreasing order of magnitude is the middle value when the number of observations is odd, or the arithmetic mean of the two middle values when the number of observations is even. Let us have an illustration. On 5-term tests in sociology, a student has made grades of 82, 93, 86, 92, and 79. Find the median for these test grades. The dataset contains 5 observations. To get the median, we have to arrange the values of the dataset in increasing order of magnitude. Since the number of observations is odd, there would only be one middle value. And that middle value is 86, and that is our median. Let's have a second example. The following are the prices in pesos per liter of diesel gasoline from 6 gas stations in Manila. The number of observations in the given dataset is 6. Arranging the dataset in increasing order, we get the following. Now, since the number of observations is even, there would be two middle values, and these are 48.8 and 49.5. So getting the average of these two middle values, which is 49.15, which is our median. Now, this slide shows the formulas for the position of the middle values. If the number of observations is odd, then the position of the single middle value is n plus 1 over 2. For example, if the number of observations is 5, then we have 5 plus 1, which is 6, divided by 2, which is 3. This means that the middle value when n equals 5 occurs at the third position. Now, if the number of observations is even, there would be two middle values, and their positions are in the n over 2 and n over 2 plus 1 observations. So for example, if the number of observations is 6, the middle values occur at 3 and 4, or at the third and the fourth observations. As a remark for the median is not greatly affected by extreme values. It is the best measure of center in terms of position in an arranged sequence. Often, it is used for curving or adjusting values to fit in a normal distribution. Also, the median divides the dataset into two equal parts. If the median is the middle value, then 50% of the dataset would be lesser than the median, and 50% of the dataset would be greater than the median. The last measure of center is the mode. The mode of a set of observations is that value which occurs most often or with the greatest frequency. Let us have an example. The following are the IQ scores of 10 teenagers. The mode of this dataset is 82 because 82 occurred 3 times and with the highest frequency. Remark for the mode. For some sets of data, it's possible that there would be more than one mode. Now also, the mode may not always exist. This is certainly true if each distinct observation occur with the same frequency. Let us illustrate the remark for the mode. Consider the following sets of data. For dataset 1, the modes are 20 and 40 because these numbers occurred twice and with the highest frequency. For dataset 2, the modes are 3, 4, and 6 because these values occurred 3 times and with the highest frequency. Let us have another illustration. Consider the following sets of data. Dataset 1, we have 90, 97, 98, 97, 90, and 98. Observe that each distinct observation occurred twice, or all the observations occurred twice. Therefore, this dataset doesn't have a mode. This is also true for dataset 2 because each observation occurred once. Therefore, dataset 2 doesn't have a mode. Another remark for the mode would be the mode is not the best measure of center since not all datasets possess this value. However, the mode is the only measure that may also be used for qualitative data. For example, which size of shirt is preferred by students or which type of transportation is preferred by students. Now you have learned about measures of central tendency. In the next video, we shall discuss the other summary measures like measures of variation and measures of position.